Students, see, in the last video, we saw the real image formed by a convex lens, isn't it? Now, I told you when the object is kept at infinity, see, when the object is kept at infinity, that time image will be formed on f2, okay, here. The size of the image, okay, will be very, very small, almost a point source, okay. When the image is kept beyond 2f1 over here, then the image, you know how to draw a ray diagram, isn't it? You're going to draw one ray like this and one ray like this. So wherever it is going to intersect, okay. So see, the image will be formed between f2 and 2f2 when you are going to keep the object at that is beyond 2f1, okay. The image here will be real image, it will be inverted, you have seen it's inverted image, okay, and diminished also. Then when you keep the object on 2f1, okay, that time see, when you are going to keep the object at 2f1, then the image will be formed at 2f2. Yes, see, it's going to go like that, and the image will be formed at 2f2. Okay, yes, see, here it will be formed. Now see, the image, again the image will be of the same size as 2f1, okay. It is an inverted image. Now see, when the object, okay, is kept, that is when the object is kept between 2f1, okay, and f1, see, when the object is kept at 2f1 and f1, okay, the image will be formed, when you kept it at 2f1, image had been formed at 2f2, isn't it? Now when you are keeping the object between 2f1 and f1, then the image will be formed beyond, see here, beyond 2f2, okay. And then when you keep the object on f1, okay, then the image will be formed at infinity. Now see, the image when when you keep it between 2f1 and f1, from 2f1, when you keep the object at 2f1, the image is going to be same size as the object. Then again further, when you go on keeping, when you keep it between 2f1 and f1, the image will start enlarging, okay. It will be bigger than the object. When you keep it on f1, the image will be very, very large. Now see, I'll show you. See this table. When you are going to keep the position of the object at infinity, okay, then the image will be formed on f2. How will be the image? Point image, okay. Nature of the image, it is real and inverted. Beyond 2f1, it is between f2 and 2f2. The size of the object will be smaller. Again, real and inverted image. Now when you keep it at 2f1, okay, image will also be formed at 2f2. Image will be of the same size. Nature of the image will be real and inverted. Then when you keep it between f1 and 2f1, the image will be formed beyond 2f2. How will be the size of the image? It will be larger, and the nature of the image will be real and inverted. Then when you keep the object at f1, then the image will be formed at infinity. So how will be the size of the image? It will be very large, okay. then real and inverted image. Now between F1 and O, that time see the image will be formed on the same side of the lens as the object, and the image will be very large, it will be virtual and erect. Okay, now see, once again let me show it to you. See, in this ray diagram, let us see. When you keep it at infinity, okay, the object where it will be formed at F2, how will be the image? The size of the image will be point source, very small, okay. And how is the nature of the image? It is real and it is inverted image. Now when you keep the object, okay, beyond 2F2, that time the image will be formed between F2 and 2F2. Okay. So again the size of the image will be very small. Okay, it is size will be small. Again it is inverted image and real image. So real and inverted image is formed. Now when you keep the object at 2F1, okay, the image will be formed at 2F2. Then the size of the image will be same size as the object, okay, and it is again real and inverted image. Now see, when you keep the object between 2F2 and F2, okay, here, that time the image will be formed between, yes, it will be formed beyond 2F2 here, okay. So the size of the image will be larger than the size of the object now, okay. The size will be larger than the object, and it will that is, it is real and inverted image. Now when you keep the object on F1, okay, that time the image will be formed at infinity, okay. Yes, the image will be formed at infinity, and the size of the image will be very large, okay, enlarged image, and it is again inverted image. Now when you keep the object, okay, between F2 and the pole of the mirror, okay, F2 and O, that time the image will be formed on the same side, okay. So when you are going to keep it between, this is F2 and this is O, isn't it? So you can see, wait, see, this is F2 and this is O. So when you keep the object between F2 and O, okay, that time you can see the ray diagram over here. See, it's going to go like that and it's going to pass like this, okay, and one more ray is going to come out like this. Now when you extend this ray, it is going to come and meet over here, okay. So the image will be formed here. So the image now, when you keep it, when you keep the object between F2 and O, that time the image will be formed on the same side as the object, okay. Now the image is large, okay. Again that is, you can see the image is very large, and the that is, it is an erect. See, I'll show you, wait. See, you can see here, it is the erect image. Otherwise you were seeing on this side, that is on the other side, isn't it? It all were inverted image, right? But now here the image is erect, okay, and it is on the same side. So it is a inverted and virtual image. So sorry, it is erect and virtual image. You can see here it is erect, isn't it? Now see, images formed by concave lenses. We can obtain the images obtained by concave lenses using the following rules. Okay, see, so how you are going to obtain the images by concave lenses? You can use the following rules. So which are those rules? When the incident ray is parallel to the principal axis, the refracted ray, when extended backwards, passes through the focus. Okay, so what is the first rule for this? The incident ray, when it is parallel to the principal axis, the refracted ray when extended. Okay, let me show it to you here. See, see here, the incident ray, okay, when it is parallel to the principal axis, okay, yes, it is going to refract like this. Okay, then what is going to happen when you extend this backwards? Okay, yes, like this, when you are going to extend this, it is going to pass through the focus. You can see it's passing through F1, isn't it? Now second, second rule, when the incident ray passes through the focus, the refracted ray is parallel to the principal axis. So when the incident ray, okay, when it is going to pass through the focus, that time the refracted ray is going to be parallel to the principal axis. Okay, so the refracted ray is going to be parallel to this principal axis. As shown in figure 7.9, okay, object PQ is placed between F1 and 2F1 in front of a concave lens. The incident ray PA, starting from point P and going parallel to the principal axis, goes along AD after refraction. If AD is extended backwards, it appears to come from F1. The incident ray PO, starting from point P and passing through O. Okay, so the incident ray PO, starting from P and passing through O, goes along the same direction after refraction. So PO intersects the extended ray AF1 at P dash. So that is P dash is the image of P. Now see, let me show this to you. See, you can see over here, okay. This is the object PQ, okay. So PA is incident ray, okay, coming out through this object PQ, okay. After refraction, it is going along AD. When you extended this backwards, it passes through the point F, okay. Now one more ray which is coming out. So one more ray which is coming out from P passes through the optical center O, okay, and because it is passing through the optical center, it goes undeviated. Now these two rays, okay, yes, see, these two rays, that is PO and AD, okay, it after intersect, that is, it is going to intersect, okay, it is going to intersect at this point P dash. So you can see here, so one ray is going like this, and see, when you extend this, it's passing through F1. This one more ray, it's passing through the optical center, and see, you can see this, it is intersecting here. So P dash Q dash, okay, this is the image formed, okay. So it is an erect image, isn't it? As the point Q is the principal axis, its image is formed along the axis at the point Q dash directly below P dash. Thus, P dash Q dash is the image of PQ. The image formed by a concave lens is always virtual, erect and smaller than the object. Okay, so how is the image formed by a concave lens? It is always virtual. Okay, you saw convex lens, it was real image, isn't it? Here the image is always virtual, okay, because it is formed on the same side of the mirror as the object. So it is virtual image. It is erect image. There you saw all were inverted image, isn't it? Now here you can see it is erect image and smaller than the object. Okay, the image is going to be smaller than the object. Students, I'll show you a small video clip regarding image formation by concave lens. Observe it closely. I have just now explained it to you. Okay, see this practically so you will understand.
Let's see the image formation by concave lens. Here are the rules. A ray of light from the object parallel to principal axis, after refraction from a concave lens, appears to diverge from the principal focus, located on the same side of the lens. In simple words, a ray of light that is parallel to principal axis after refraction from the lens, it becomes diverging. So for the observer on the right hand side, this ray of light appears to be coming from a point that is F2.
See, you know, in convex lens what was happening? Wait, I'll show it to you. See, in convex lens what was happening, you know, the rays of light were coming like this, isn't it? That means it was converging. But here in case of concave lens what is happening? It is going the other way, right? So that means what? It is coming like this. Okay, see, it's coming like this and it is going in this way. That means it appears to be diverging, isn't it? Yes, from the principal focus. And one more thing, see, the principal focus which is there, okay, it is on this side only, on the same side, okay.
Which is the principal focus, located on the same side of the lens. A ray of light, appearing to meet at principal focus of a concave lens, after refraction, will emerge parallel to the principal axis. This we have already seen in the
See, you know, the ray of light, okay, the ray of, see it, you can see here this ray, okay, after refraction it is passing parallel. This is principal axis. You can see this is parallel, isn't it? The refracted ray, okay, it is coming out parallel to the principal axis, means a incident ray which is passing. If you extend this, you can see it appears to be passing through the focus, isn't it? That means, see, a ray of light appearing to meet means what? It appears as though it is going to meet. It's not actually meeting, okay, it appears to meet. You can see the dotted line, okay. When you extend it, it is going to pass through F1, okay, and such type of rays will be parallel to the principal axis.
Definition of principal focus. A ray of light passing through optical center of a concave lens will emerge without any deviation.
This also you know, see, a ray of light, okay, which is passing through the optical center, okay, will pass without any deviation. There will not be any refraction of light.
This rule is quite similar to the rule of convex lens, that a ray of light which is passing through optical center of a convex lens will pass undeviated. Similarly, for the concave lens, a ray of light which is passing through optical center will pass undeviated after refraction from the lens. Let's start the image formation when the object is at infinity. The rays of light that is coming is parallel to principal axis, and after refraction, they both becomes diverging, since it's a diverging lens. Now for an observer, which is looking from this side, these two rays appear to be coming from a common point. That is the principal focus, on the same side of lens, from where the rays are coming. So these two refracted rays appear to meet at this point, or say appear to come from this point, so we say the image is formed at focus. And it is virtual image, and it is highly diminished, or say it is point-sized. Second case, when object is placed between infinity and optical center. So here is our extended object AB. A ray of light from point A goes parallel to principal axis, and it actually becomes diverging of a refraction from the lens. The second ray of light, which goes through optical center, passes undeviated after refraction from the lens. These two rays of light appear to meet at suppose this point. And so this point will be actually the image of point A, which will be the virtual image of point A. And we join this point from principal axis. We get a virtual image of object AB as A dash B dash. So the image is formed between focus and lens on the same side as the object. The image is virtual and erect image. And it is diminished, that is smaller than the object. So here we see the summary of image formed by concave lens when the object is at infinity. The image is formed at focus, which is virtual and point-sized. And when object is placed anywhere between infinity and optical center, the image is formed between optical center and focus, on the same side as the object. And the image is virtual and erect, and smaller in size.
So students, I am sure you must have understood this by seeing the video clip, isn't it? How the images are formed by a concave lens. So when the object is placed at infinity, the image is formed on the focus f1, isn't it? And the size of the image, it is very, very small, almost point size. Then what is the nature of the image? Virtual and erect. Now when you keep the object anywhere between optical center O and infinity, okay, between O and infinity, that time the image will be formed between the optical center and focus f1, okay, optical center, okay, O and focus f1. And how is the image, size of the image? It's going to be small, and the nature of the image will be virtual, okay, that is on the same side of the mirror, and it will be erect. Now the Cartesian sign, okay, just recall this. What is the Cartesian sign convention used for spherical mirrors? Okay, so let us see the sign convention in the next video.